Assalamu alaikum everyone. My name is Al Faisal Shiraji. This is our course Digital Logic and Circuit, and this is the assignment of our final term. The assignment topic is Digital Parking System. My ID is 235256662. As the assignment shows that uh, for the total holding up car is B plus F plus H. According to my ID, it is 3 plus 6 plus 2, which is 11. So I can say that in my assignment, the garage holds up to 11 cars, and when it will take space 11 cars, it will show full. And um, if the garage is holding more than 11 cars, it will show there is no space available. We have for the display sensor, we have used a 7-segment diode display. For that, we have used an IC sensor. From the IC sensors, there are getting two sensors into one is entry and one is exit. The entry and exit sensors are connected with the counter. The counter is taking the pulse from the entry and exit sensor through the IC, and from the counter, the reading is going to the decoder. The decoder is connected with the comparator. The decoder is connected with the comparator, and the comparator is working in two mode, which is monostable and astable. For the monostable mode, it is one mode which is not changing, and the astable mode is the continuous changing mode, as we know. So when there is 11 cards, the monostable mode will show full and display full, and when the garage is fulfilled with less than 11 car, it will show there is more space available from astable mode. For the flow diagram, after starting, the counter initializes itself and takes sensors automatically. Then the sensors is divided into two parts. First one checks there is entry, and the second one is checking the exit sensor. Both sensors are connected to the counter, which is updating from the sensor. And if the counter is reading 11 cards, then it will show full, and if it readings less than 11, it will show there is more space available, and this process is keep resetting and repeating. For the counter diagram, we will use a 4-bit synchronous counter, which is 4-bit synchronous counter for highest 11 cars, where the entry is 1, which is resembling up, and the exit is down, which is resembling 0. From the diagram, we can see if if the entry is happening, then it is changing from 0000 from 0001, and for the down, it is changing to the starting, which is 0000. This is the transitional table. We will use a JK flip-flop for the counter. This is the 4-bit up-down counter. This is the K-map from this table, where we used a simple logic to grouping, which is we can group up to 2, 4, 6, and 8, and those logic were used in this K-map. And this is the K-map for down. This is the block diagram where we have used 4 JK flip-flops which are connected to each another and getting value from one another to show the result. This is the 555 timer. As we know that the first one mode is monostable, which is displaying the full, and the second mode is astable, which is displaying the space available. We have connected the both VCC to the main power circuit, and there are 2 resistors for each 555 counter, and there are also 2 capacitors for each 555 counter. This is the calculation part where we have calculated T and the resistance of R1 and R2, and also the microfarad of the capacitors. From the calculation part, we can say that we will use the 250 microfarad in this 555 counters, because if we use 450 microfarad, the resistance over the resistors is too much low that we can get the value properly. But if we use 250 microfarads, then the resistance in R1 and R2 is very high, which is help us to get the accurate reading to displaying the full and space available. So from the calculation part, we will say that we can use 250 microfarad for this digital parking system. This is the clock period, where the clock period is 1 millisecond. From the calculation, TH is equals to 56.31 and TL is equals to 29. Here we can see that um, the toggle will be happened in for each cycle. So we can see that 0, 1, 2, 3, the output is same, which is 1, 0, 1, 0, 1, 0, and 1, 0. So it will toggle in 4 cycles. So after 4 cycles, it is changed to 0, 1, 0, 1, 0, 1, 0, 1. And so that's how the time period is working over here. This is the Verilog HDL code for the digital parking system. And for the last question, there are so many limitations in this system because it cannot be adjusted dynamically. The entry or exits are limited because there are only 11 space over there, and so it is not for big operation. It is more suitable for a basic study and show the students how a timer, a 555 timer, comparator, and periodic table K-maps are used for. To improve, a microcontroller can be used to expand this operation, because the microcontroller will help to show the display and the sensors more accurately, so the numbers and entry and exit will be more precise. Thank you so much, everyone. Assalamu alaikum.